Good morning, all. Today, being kind of Friday, I was having a bunch of technical difficulties yesterday, so I think I'm going to be able to make this video work. I've opened up our classwork for Thursday. I already see that 9 of us turned it in. That's great. This video is going to help us make sure that we understand what to do for our lab. That was assigned yesterday due today. So, I view the assignment. I'll open up the Dart. So open the Dart versus the Dart 2.0 doc shared, which is this. Follow the directions in the doc to complete the lab. And so when I click on this, I'll open here. Wednesday's assignment was to make your two planes, the Dart and the Dart 2.0. All right. Each are similar, but we know that from our experimental question, we are trying to answer, do modifications always make things better? And in this specific case, does the modification from the Dart to the Dart 2.0 make the Dart 2.0 better than the Dart? That is what we'll need to find out today. So Wednesday, you've built your two planes. Boom and boom. If you're not sure how to make the planes, go back to Wednesday, October 7th, watch the two instructional videos, and they'll help you make the plane. But we're going to start with step 3. Decide how you will throw each plane. Highlight the rule set in a box that you'll follow. So I can decide to throw the first rule set or the second rule set. As I read them, I will throw both planes hard and straight out in front of me and release at a 15-degree angle, or I will throw both planes softly and straight out in front of me and release at a 15-degree angle. I think I'm going to follow rule set. I think I'll follow the first rule set. And I want to do that just because I think throwing it hard is better for the Dart, because the Dart kind of sounds like something fast, so I should probably throw it hard to make it go fast. Step 4, how will you decide if the plane flies better? Highlight one experiment in a box you want to test. You get to pick this one. So you can decide if you want to do an experiment where the plane has more hang time, meaning from the time you release the plane to when it hits the ground, how long does it stay in the air? I can choose the experiment, the faster plane is the better plane, or you can choose the plane that flies straighter is the better plane. I actually think I want to do the straighter plane. The plane that flies straighter makes it better. I just think that's probably a more efficient way to fly. If you're flying in a plane, you don't want to, and you're going from, say, Minneapolis to Chicago, so Minneapolis is here, Chicago's here, you know, it's about a 7-hour drive, maybe an hour and a half flight. I don't want to go to Iowa and then over to Illinois. I want to go straight to Chicago, you know. So I think the straighter plane would be the better plane. So step 5. This one's a little more challenging, and I try to give some more detailed steps for it. Create a prediction. So that's like you are going to make a prediction for this experiment. Which plane will fly better in your chosen experiment? Why do you think so? Include a design feature of your plane or explain how your plane will overcome force. That is what we're looking for in our prediction. I made an example prediction. I believe that the Dart 2.0 will fly faster than the Dart because the plane feels heavier and takes up less space, so it won't be slowed down by as much drag. And that's a pretty good prediction because it identified which experiment I was going to try and do, the fly faster one, so that would be the middle one up here. I identified a design feature of the plane. I said the plane feels heavier and it takes up less space because, you know, the Dart is smaller and its wings aren't as big as the Dart 2.0, is smaller and doesn't take up as much space as the Dart. And I explained that that's good because it won't be slowed down by as much drag. Because remember we said that drag slows a plane down. It's all that air resistance. So I'm going to recreate a prediction for the experiment I chose to do. I would say that I believe that, which plane is going to fly straighter? I think, you know what? I think that the Dart is going to fly, or will fly straighter than the Dart 2.0 because so let's see, as I look at my plane, okay, I already notice on my plane that here's my Dart 2.0, here's my Dart. Look at the nose, you know? The nose on the Dart 2.0 is bent and kind of out of shape, whereas the Dart has a straighter nose. And so I'll say because the Dart has a straighter nose than the Dart 2.0. And I remember from our lessons Monday and Wednesday that a straighter nose helps steer the plane to fly straighter. Okay, so I have the experiment that I'm doing because it will fly straighter. So I'm actually going to modify that highlight. I'm going to change that to an orange. Faster than the Dart 2.0 because the Dart has a straighter nose. And so I'm highlighting that in orange because I have the design feature now. And I identified how it will overcome a force. And it flies, it can overcome a force or just how the design feature is going to help. A straighter nose helps steer the plane to fly straighter. So how does that overcome a force? Well, straighter means that it is less affected by the air. So it actually, it also helps steer the plane to fly straighter. So there is less air resistance impacting my flight. Yeah, okay. So that makes more sense. Great. So I've included all three parts: my experiment, the design feature, how it overcomes the force. All right. So in step 6, we test the Dart and the Dart 2.0 at least 3 times. Remember the rules you followed from step 3. I said that I would throw the planes hard and straight out in front of me at a 15-degree angle. All right. So that's what I'm going to do. I'm going to take my planes, throw them straight out at a 15-degree angle, so slightly up, really hard. When I do that 3 times, I'll record my results. So at this point, I'm actually going to pause the video to do my tests. What I did was I just tested my planes. I'm in the classroom today. And so I'm going to try to flip it around. I know it's going to be kind of hard to see, but kind of right there on the floor is the Dart 2.0, and way kind of over there by the door is the Dart. So when I make my observations, I want to focus on my experiment, and since I said the straighter plane is the better plane, it looks like in my first trial the Dart 2.0 flew straighter than the Dart. So I'm going to pause my video to record. I don't need to pause. I'm going to walk my computer back, and I'm going to say the Dart flew further right, flew further to the right. It was less straight. And the Dart 2.0 flew fairly straight. So kind of straight, but it was, was slightly right. Okay, so I made those observations. And now, since I kind of showed you a model, I'm going to pause it again, this video again, and I'm going to test each plane at least 2 more times. Hi again. I paused the video to run the rest of my experiments. You'll notice a change in my test throw 2 and test throw 3 for both planes. It didn't feel like any time for you if you're watching this. So take a look at the dart. So let's just review the observations before we continue to any other steps. The dart. In the first throw, it flew further to the right, less straight, so pretty far off center. If you imagine the line, it took off way right. The second throw, it actually flew kind of straight and it was slightly left, so not bad. And then in my last throw, it just took off and flew wide right. Like it was a lot like the first throw where it just ended up by the door. Now the Dart 2.0. Looks like in the Dart 2.0, my observations were that the plane flew fairly straight but was slightly right. It flew fairly straight in the second throw but slightly left. And then I repeated actually those same observations. It almost ended up in the exact same spot where the plane flew fairly straight and it was slightly left. So, compare your observations of the Dart and the Dart 2.0. Which plane flew better in your experiment? So you kind of have to circle back to what experiment you're running. The plane that flies straighter is the better plane. My prediction, I thought that the Dart will fly straighter than the Dart 2.0 because it has a straighter nose, and a straighter nose helps steer the plane to fly straighter, so there's less air resistance impacting my flight. So type your answer here. Which plane actually flew better? Which plane actually flew straighter? I learned that the Dart 2.0 actually flew straighter. Okay, the Dart 2.0 actually flew better, so I just state which plane flew better in my experiment. If you chose to do which plane flew faster, you tell me that. If you decided to do which plane would have the higher hang time, you tell me which plane had more hang time. But I was just looking at straightness for this experiment. So which plane would fly straighter? Was my prediction correct? Explain why or why not. Look back at step 5 for your prediction. Oh, I should actually say that for... Yeah, that's fine. So my prediction was not correct. So I would say that like I thought that the Dart would fly straighter because it had the straighter nose, so it would be less impacted by air resistance. However, I was wrong. And what I actually noticed was that like when I was holding the planes, the Dart 2.0 felt heavier than the Dart, even though I used the same amount of paper, but the Dart 2.0 I also had a couple pieces of tape. Okay, so there is a little bit of difference in mass there. However, the Dart 2.0 flew straighter. And I need to add the quotes because that's the name of the plane. I think that the Dart 2.0 flew straighter because, and it's kind of like what I said, it felt heavier when I was holding it. And since it felt heavier, it was less affected by air resistance. Less affected or less impacted, or like the air that it was flying through couldn't alter the flight as badly. Okay, and so that